Welcome back to another math lesson where we keep math simple and easy to understand. This is your exam review, part 7. Now, I've already spoken about this part, so just check out the video. So let's get started. So in the first part, whenever you are asked to evaluate the function for the given value of x, all you have to do is wherever there's f of -2, then all it means is wherever there's a x, put a -2. So basically I have f of -2, open the bracket, and that's equal to, open the bracket, -2 square plus 3, open the bracket, -2, and f of -2 is equal to, now you can put that in your calculator and you should get an answer of -2. And now you do the same for b. So wherever there's a x, we're going to put a 4. So f of 4 equals to 3, open the bracket, 4 square minus 11, just make this 11 properly, minus 11, so f of 4, that's equal to 37. And you do the same for c. So wherever there's an x, we're going to put a -1, so f of -1, that's equal to 4, open the bracket, -1, close, plus 5, open the bracket, -1, plus 15. So f of -1 is equal to 6. Now at this point, if you like, you can pause the video and then you can do D, E, and F, and then come back to check your answers. Right, hopefully you've done that, and now we can just check. So f of 7 equals to, open the bracket, 7 square plus 7. And if you put that in your calculator, you should get an answer of 56. For E, we have 5 -4, open the bracket, 5 square minus 7, and then you get 5, that's equal to -126. And you do the same for F. So all I'm doing is I'm just putting a -2 wherever there's an x. So and that answer is 14. So what's important about evaluation is whenever you see whatever is in the bracket, f of whatever is in the bracket, you just put that in the place of x. So f and whatever is inside the bracket, you put that in the place of x. F of something, and you just put that something wherever there's a x, and so on and so forth. All right. Now, how do we find the zeros of a quadratic function? Now this is very important. Now all you have to do is you have to make sure that it's in standard form, and the standard form is ax squared plus bx plus c is equal to 0. So that's our standard form. So if you look at number 1, you can see number 1 is in standard form. So our a is 1. Now we know that there's a 1. If there's nothing there, it's understood to mean that there's a 1. So my b is -3 and my c is -4. Right, and now you can take out your calculator and you can use mode, and then equation, and then number 3, and then you put in your a, your b, and your c. Right, seeing that we're working with x, so we're going to have x in the bracket, and now if I put in 1 for my a, -3 for my b, and -4 for my c, my first x value is 4, and my second x value is -1. Now what you should remember is when you put the 4 inside of the bracket, you take the opposite of +4. So what's the opposite of +4? -4. So what's the opposite of -1? That will be +1. And then don't forget to put the 0. And then you just say x minus 4 equal to 0, or x plus 1 equal to 0, x is equal to 4, or x is equal to -1. So that's how you find the zeros of a quadratic function. So make sure that it's in standard form, and we can see that this function is in fact in standard form. So we can identify our a, which is 1, our b, which is 5, and our c, which is -6. We open up our bracket, put it equal to 0, use our calculator, mode, then 5, and then number 3 for equation. Now we can put in our a is 1, our b is 5, and our c is -6, and our first x value is 1, and our second x value is -6. And now in the bracket we're going to take the opposite of 1 and opposite of -6. Right, so we have excuse me, we have x minus 1 because we take the opposite of +1, and then we're going to have x, what's the opposite of -6? +6. And then we just say x minus 1 equal to 0, or x plus 6 equal to 0. So x is equal to 1, or x is equal to -6. Right, let's check again. Is it in standard form? Yes, it is in standard form. We identify our a, b's, and c's. So 6, -9, -15. So we have, open the bracket, equal to 0. So our a is 6, our b is -9, and our c is -15. And we see our first x value is 5/2, and our second x value is -1. Now all you have to remember when you get a fraction, just move the 2 so that it becomes 2x. Then we have 5. We're actually working in reverse, and then we take the 5 over, which is negative. So then it's going to be 2x minus 5, and then of course we have -1 there, and that's going to be x plus 1, and then 2x minus 5 equal to 0, or x plus 1 equal to 0. So 2x equals to 5, or x equals to -1. So then if we divide both sides by 2, cancel, x is equal to 5/2. Right, now at this point you can pause the video, do number 4, 5, and 6, and then come back to check your answers. So hopefully you've done that, and now we do the same process. Now for number 4, I just want you to pay attention here quickly. So for number 4, we have x squared. We don't have a b, but what we can do is we can do this trick: plus 0x for our b and minus 100. It's exactly the same as this one. All right, so now it makes it much easier for us to identify our a, b's, and c's. So a is 1, b is 0, c is -100. So we open up our brackets. So we have x. Now for our a we have 1, our b is 0, and our c is -100. So we have our x1 is equal to 10, and our x2 is equal to -10. Now you know what we're going to do is we're going to take the opposite of +10, which is -10, and then we're going to take the opposite of -10 and put the opposite, which is +10, inside of the bracket. So now we have x minus 10 equals to 0, or x plus 10 equal to 0, x equals to 10, or x equals to -10. Now once again we're checking if our equation is in standard form. Yes, it is. So a is 81, our b is -90, and our c is 25. Use our calculator. So a is 81, our b is -90, and our c is 25. Once again we get a fraction, x equals to 5/9, the first x value. The second x value we get. Now if you don't get this second x value, it means it is exactly the same as the first x value. So go ahead and just repeat the same x value. All right, because in this example we don't have a second x value, which means it is the same x value. All right, so just keep that in mind. And now we open up our brackets, and whenever you have a fraction, just take the denominator and move it next to the x. So then it's going to be 9x, and then obviously if we take the +5 from the right hand side to the left hand side, that's going to be -5, and we just repeat the same in the other bracket because they are exactly the same. And now we can just say 9x minus 5 equals to 0, or 9x minus 5 equals to 0. So now we have 9x equals to 5, or 9x equals to 5. Divide both sides by 9. The 9's cancel. X is equal to 5/9. And of course it's exactly the same on the other side. Right, and for the last one we check and make sure that it's in standard form, which it is. So a is 1, our b is 12, and our c is 32. We open up our two brackets, we put it equal to 0, we use our calculator, and we put in our 1 for a, our b is 12, and our c is 32. And we can see for the first x value, I'll just write it here, for the first x value we have negative 4, and for the second x value we have negative 8. So, and now obviously in the bracket we're going to have negative positive 4, and negative 8 becomes positive 8. So x plus 4 equals to 0, or x plus 8 equals to 0, and now x is equal to negative 4, or x equals to negative 8. So what's really important here? What's important here is you have to make sure that it's in standard form and identify your A, your B's, and your C's. And I think also what's really important, if you get an answer as a fraction, just move the denominator next to the x and then take the opposite of the number. If it's positive, then it's obviously going to be negative, as you can see there. If your first if you only get one x value, just remember there's also another one, but it doesn't show on the calculator, but it's exactly the same. All right, so that's, I think, the most important bits and pieces that you should remember. Now for the excuse me, for the next part, which is find the intercepts. So if the question is find the slope and y-intercept of the graph of each equation. Now for graphs, and that's very specific to linear graphs or line graphs, just remember that your form is y is equal to mx plus b, where m is the slope of the line and the b, that's the y-intercept. Now, as you can see, I've color-coded the bits and pieces, so you can see that's our slope-intercept form. And here for A, we have the y, the equal, the m, which is represented by a number, in this case is 3. So our slope is 3. Now how do we get the y-intercept? Well, we set x equal to 0. So wherever there's an x, we just put a 0. So then it's going to be y equals to 3, open the bracket, put a 0, plus 1, y is equal to 3 times 0, that's 0, we don't need to write it, and then what's left is 1. Done. So our coordinate then will be 0, 1. So that's our y-intercept. Now y 0 because we say put x equal to 0. And we can do the same for b. We check to make sure that it's in slope-intercept form, which it is, and now we can identify our slope in this case. I think what's important, what you should remember is it's the number in front of x, right? So in this case, we can see the number in front of x is 3. And now, to get the y-intercept, we just put a 0 wherever there's a x. So we have 3, open bracket 0, minus 5. So y is equal to 3 times 0, 0. We don't need to write the 0. So what's left? Minus 5. So the coordinate then will be 0, negative 5. For C, now we don't have a number and x in C, as you can see there. We only have a b. So the slope there is 0. All right. And of course, the y-intercept here, you can see it very clearly, is 4. So because there's no need to put a 0 in the place of x, because we do not have an x, and it just makes sense. How can you put something there that doesn't exist? So 0 and 4. The last one, now you can try the last one. You can pause the video, do it, come back, check your answer. Hopefully you've done that. Now for C we have -3 for the slope, and then for the y-intercept, -3 times 0, 0, +3 remains, and our coordinate is 0, 3. And that's basically how we do that. And now, how do we find the intercepts? In other words, how do we find the x and y intercepts for the following quadratic functions? So what you should remember is, this is our standard form, ax squared plus bx plus c equal to 0. We have to make sure that our equation is in standard form. So, but before we get to that part, we can see here the y is here, and then equals to, and then everything else is on the right hand side, which is not quite the standard form. So what you do is you can just rewrite everything as is. So x squared plus 2x minus 2, and then put it equal to 0. And now we can identify our a, our b, and our c. So our a is 1, our b is 2, and our c is -2. So let me just go ahead and put that in. Now you can use your calculator and go to mode, then number 5, which is equation, and then number 3, you will see that standard form, and then of course you can put in your a, your b, and your c. All right, so let's go ahead and do that. So I open up my brackets, I put it equal to 0. Because we're working with x, I'm just going to put x in the brackets. Now, so if I put my a for as 1, put equal to, then put 2, put equal to, and then put -2 for c equal to, we get, for the first x value, we get this weird looking first x value, which is -1 plus the square root of 3. For the second x value, we get -1 minus 3. And now we just put that in our calculator, but remember, we take the opposite. So what's the opposite of -1? +1. What's the opposite of positive the square root of 3? Negative the square root of 3. So +1, negative square root of 3, and then opposite of -1, +1. What's the opposite of negative the square root of 3? Obviously positive square root of 3. And then we just put it equal to 0, write the same thing down again, put it equal to 0, or x plus 1 plus the square root of 3 equal to 0. So x is equal to, now we just take this whole thing over from the left hand side to the right hand side, and then it becomes -1 plus the square root of 3. You can see it's basically the same as the first x value. Or x equals to, it's going to be definitely the second x value, which is -1 minus square root of 3. Great. So now that we have our x-intercepts, now we can go ahead and find the y-intercept. Y-intercept, very easy. We write down our equation. Y equals to x squared plus 2x minus 2. As you can see right there. And wherever there's a x, we just put a 0. And now we can evaluate. So that's 0, that's 0. So what's left? -2. And that's how we do those type of questions, my students. Now let's look at one more. Just like before, we check to make sure that it's in standard form. which is ax squared plus bx plus c equal to 0. Identify your a, your b, and your c. So my a is 1, my b is 4, my c is 3. Just go ahead and I open up my brackets, I put it equal to 0. Because we're working with x, I'm going to have x in the bracket. So if I put that in my calculator, a is equal to 1, so 1 for a, 4 for b, and 3 for c. My first x value is -1, which is going to become +1 in the bracket. My second x value is going to become -3, and in the bracket it's going to become +3. And now I just set whatever's in the bracket, x plus 1, put it equal to 0, or whatever's in the bracket, x plus 3 equal to 0. And then we just solve for x. So x equals to -1, or x equals to -3. Now to get the y-intercept, we set x equal to 0. So y equals to x squared plus 4x plus 3. Y equals to, open the bracket, put a 0, square plus 4, open the bracket, put a 0, plus 3. So y is equal to 3. Why? Because that's 0, and what's left is 3. And that's how we find the x and y intercept for this particular question. Now you can do this one on your own and pause the video, do it, and then come back and check your answer whether it's right or wrong. Right, welcome back. So hopefully you've done that. So my a is 1, my b is -11, my c is 30. I'm going to open up my brackets. I'm going to put it equal to 0 because we're working with x. I'll have x there. Then once again, you can see it's becoming redundant now. It's a pattern. So 1 for a, b -11, c is 30. So my x1 is going to be 6 and my x2 is going to be 5. So you know, we take the opposite of 6, which is -6. We take the opposite of +5, which is -5. And now we put whatever's in the bracket equal to 0 or x minus 5. Don't forget to write all. So x is equal to 6 or x is equal to 5. So we found our x-intercepts, and now we just find the y-intercepts, and now the y-intercept, we just rewrite the equation again. And wherever there's an x, we're going to put a 0. So y is equal to 30. And that's how we do that one. You can try to do this one on your own. Pause the video, give it a try, come back, check your answer. Hopefully you've done that. So let's see, my a is 1, my b is -2, my c is -15. So my a is 1, my b is -2, my c is -15. We open up our brackets, put it equal to 0. Because we're working with x, we put x in the brackets. So 1 for a, -2 for b, -15 for c, and our answer, our first x value is 5, our second x value is 3. Now we put the opposite of positive 5 in the bracket, which is negative 5. We put the opposite of positive 3 inside the bracket, that's negative 3. And whatever's in the bracket, we put it equal to 0, or x minus 3 equal to 0. So x is equal to 5, or x is equal to 3. Great, we have our x-intercepts. Now we just move on to find the y-intercepts. So we write on our equation, y is equal to x squared minus 2x minus 15. So y is equal to, wherever there's an x, I'm going to put a 0. So 0 squared minus 2, 0 minus 15. And of course, our answer is minus 15. Great. Hopefully you've got that correct, and congratulations. Excellent. Now, let's move on to another part, and that is, how do we find the vertex of the following quadratic function? Now, let me just recap very quickly. Now, remember, when we talk about a quadratic function, we either talk about a smiley face, and that is when a is greater than 0. Or in other words, when a is positive. Or we talk about a sad face, when a is less than 0. In other words, negative. All right. Now we have to make sure that it's in standard form. In this case, it is not. So what do? Whenever you see brackets, you have to make sure that you multiply them out. All right. And also very, very, very important, that is, whenever you see f of x, that is the same as y. So I'm just go ahead and write a y in the place of f of x equals to x times x, that will be x squared, x times positive 2, that's positive 2x, negative 3 times x, that's negative 3x, negative 3 times positive 2, that's negative 6. So y is equal to, is there any other x squared besides this one? No, of course not. So we just rewrite it again. These two are like terms. Positive 2x minus 3x, that's negative 1x. And then, of course, negative 6. Now, my a is 1, as you can see there. My b is negative 1. And my c is negative 6. Right, great. Now, the vertex works slightly different. Now, the reason why I've mentioned this in the first place, because the vertex is basically the place where the graph turns. So if it's positive, it turns right there at that particular point, and it's got a coordinate, x value there, and a y value. If it turns here, it will have the same x value and a y value. All right. So basically, what we're trying to find out here is where the graph turns. All right. So we can see clearly the a is positive, so it's definitely going to look something like a smiley face. And what we want to find out now is, where does it turn? So the vertex. So what we do is we use a formula, and that formula is x equals to negative b over 2a. So I'm going to just substitute. So x is equal to minus, what's my b and what's my a? So my b is negative 1 and my a is 1. Now, of course, you can just use a calculator to evaluate this, and you'll see negative and negative, that's positive. So we have positive 1 in the numerator and 2 times 1, which is 2. So we have a half for the x part. So in other words, for this part. So it's a half. And now we just need to figure out the y part. So what do? To get the y part, we use the x part to find the y part. So remember what I said, wherever there's a f of x, you can put a y. what's our equation? X squared minus 1x minus 6. So y is equal to, open the bracket, square minus 1, open the bracket, minus 6. So we have a half, and then that's going to become, if you do that on your calculator, you should get an answer of, and I can hear one of the students are saying y is equal to negative 25 over 4. So negative 25 over 4. So where does the graph turn? The graph basically turns at a half and negative 25 over 4. All right, so now that you get it, now let's move a little bit faster. Now once again, it's similar to A. So what did we do in A? We see brackets. We're going to multiply it out, but before we do that, we have to make sure that it's in standard form, and that's the reason why we multiply that. So we said that f of x, wherever there's f of x or g of x, it doesn't really matter what letter it is, as long as you need to know is it represents a y, and that's equal to x times x, x squared, positive 3x, negative 3x, and then please don't make this mistake. A lot of students say negative 3 times positive 3 is negative 6, which is not true. So the answer is negative 9. All right. Then y is equal to x squared. The positive 3 and the negative 3 cancels out. So my answer is 9, negative 9. Identify my A, my B, and C. Now, if you can recall back to what we did at the beginning, when we did evaluations, or what was it, the second part, remember we said that whenever we have something like this and we need a B, we can just substitute it with a 0x, just so that it looks in standard form. Excuse me. So my A is 1, my B is 0, and my C is negative 9. So x is equal to negative, what's my B? My B is 0, and my A is 1. X is equal to, you can do the evaluation on your calculator just to check, 0 on the top and 2, so our answer will be 0. Now, what do we do with the 0? Well, we use that 0 and we substitute it into our equation. So we've got our x part, which is 0. Now, for the y part, so I'm just going to just rewrite this again. So x squared minus 9. So y is equal to, open the bracket, put a 0, square minus 9. And you can see that if you evaluate that, that becomes negative 9. So is this a happy face or sad face? Well, we can see it's a happy face. Why? Because A is 1. So it will turn at 0 and negative 9. Great. You can do this one on your own and then come back to the video and check whether your answer is correct. So now here you can see we have g of x, but it still means y. All right, so it doesn't really matter what this letter is. It can be any letter of the alphabet, as long as you know it represents a y. All right, in this case, we don't need to multiply out because it's already in standard form. So all I'm going to do is I'm just going to rewrite the g of x as y, and everything else stays the same. So my A is 5, my B is negative 6, and my C is negative 8. I'm going to substitute now my B and my A value. So what's my b value? My b value is -6 and my a value is 5. So if you evaluate that in your calculator, you get negative and negative, that's positive. So you get 6/10. Now you can simplify that a little bit more. What can go into 6? It can also go into 10, 2 can go into 6, 3 times, 2 can go into 10, 5 times. So the x part, our vertex, is 3/5. Now what do we do with this 3/5? We substitute it back into the equation to get the y. So the y is equal to 5x squared. I'm just rewriting my equation. So y is equal to 5 open bracket 3/5 squared so we have 5 open the bracket 3/5 3/5 minus 6 open the bracket 3/5 close the bracket and then minus 8. So we get an answer of -49/5. So that will be -49/5. Now if you look at the a, we can see the a is positive, so it's going to be a smiley face. And where it turns, it's going to be at 3 and 5 and -49/5. Great. And now let's do the last one. Now the last one, you can do it on your own, then come back, check your answer to make sure whether you understand or not, because if you're just going to watch the videos, it's not really going to help you that much. All right, so just keep that in mind. All right, so first of all, we have to check and make sure that it's in standard form. So yes, it is. So I'm going to identify my a, which is 1, my b, which is 5, and my c, which is 4. I'm going to substitute. So my b is 5 and my c is 4. So now we have -5/8. How do we get the y part? I'm just going to rewrite the f of x as y. So we have, open the bracket, -5/8, close the bracket, squared, plus 5, open the bracket, -5/8, close the bracket, and add 4. We get an answer of 81/64. Now, if you look at the A, we can see it's a happy face. So where the graph turns, or the vertex, that will be -5/8 and 81/64. Great. Now, let's focus on the next part. So the next part is like evaluation. Well, it is evaluation, right? So all we do is evaluate the following functions to these values of the domain. What does domain mean? Domain means x values. So that means x values. Right, so we have 3 x values, 2, 3 and 4, and wherever there's an x, I'm going to put that in those places. All right, so we'll start off with 2. If I put 2 in there, evaluate this part, I get 12. If I put in 3, I get 32. If I put in 4, I get 36. Same question, different x values and obviously different equation. So if I put in -1, I get out a -6. If I put in 0, I get -1. And if I put in 1, I get out a 4. And that's basically it. Straightforward, to the point, nothing magical there. Right, now let's talk about variations. Now with variation, there are a few things that you should know, and that is the direct variation. We have y equals to kx, where k is the constant of variation. For indirect variation, or another word for indirect variation is also inverse variation. The formula there will be y equals to k over x. All right, so just keep that in mind. But this is, I think, one of the most important parts, and that is when we have a table of values, and you will see it now in the next example coming up. We have to divide the y with the x to get the constant of variation. That is for direct variation. And when we, for inverse variation or indirect variation, we multiply to get the k. All right. But before we get to that part, let's just focus on this problem. Now, if y varies directly as x and y equal to 28, and when x equals 7, find y when x is equal to 15. Now, what you should know is use the first and second values to get k. Now, what do I mean by that? So, can you see that the y equals to 28, that's mentioned first, and x equal to 7, that's mentioned second. So, and here's the magic word, directly. So we use direct variation, which means we use this formula. So let me just write that formula down. Y equals to k x. So what is my y value? My y value is 28 equals to, my k is still there. What is my x value? My x value is 7. I bring down my 28. K times 7, that will be 7k. And now we just divide both sides by 7. The 7 and 7 cancels out. On the right hand side we have just k, and if we say 28 and divide it by 7, we get an answer of 4. We have our k value. All right, we used our first and second value to find k. Now we have to write it back into the original equation. Y equals to, what's our k? Our k is 4, and then a x. So this is basically what we're looking for. This 3 dots just basically mean therefore. Okay, no need to write it. If you want to, you can. If you don't want to, no problem. Right, now only when you have k, then use the last value. So you can see when we read the question, this was the first value, this was the second value, and this is obviously the last value. Now we can use the last value. But now how are we going to use it? We're going to use it in our formula, which is 4 y is equal to 4x. So y equals to, my 4 is still there, I'm going to open up my bracket, and now I'm going to put 15 in the place of x. So y is equal to 15 times 4, that will give us 60. And that's how we do that. So what's really important is use the first and second value to find k. Then once you have k, you have to put it in the general form, and then use the last value to find the y. And also very important, look for keywords like directly. If it would have said indirect, then we would have used this formula. All right, so just keep that in mind. All right, let's do one more. So at this point, you can attempt it and come back and check your answer. So we're going to look at keywords. So that will be directly. So what does that tell us? We're going to use this formula. Now, this is our first value, and this is our second value, and of course this is our last value. Right, so because we're going to use this formula, I'm just going to write it down. And now I'm going to substitute y, that's 8. We don't have k yet. Yx, that is 2, that goes in there. And now keep the 8 on the left hand side, multiply the k with the 2, we have 2k. Divide both sides by 2, the 2's and the 2 cancels out. On the right hand side I just have k and on the left hand side 8 divided by 2, that will be 4. Therefore we write it in the original equation, which is y equals to, what is our k now? K is 4, and then we just put a x. So that is our answer. Now that we have k, only when you have k, then use the last value. Right, so I'm going to write this down again. And now y is equal to 4, open the bracket, and put a 4 there. So y is equal to 4 times 4, 16. And that's basically how we do direct variation problems. Now, what if we get a table? Right, now remember what I said at the beginning when we spoke about direct and indirect variation. We make use of these two formulae. So if the question is determine whether each table represents direct variation or inverse variation or neither, find the constant of variation. Okay, so first we need to determine whether it's direct or indirect or inverse or neither. All right, so when we want to test if the table is a direct variation, we make use of this formula. Now what does that mean? It means take the y value divided by the x value, and then you'll get an answer, and it must be the same answer for all other values. So let me show you what I mean. So the formula is y divided by x equals to k. So here's my y column and here's my x column. So you can see these values here in the y column, values in the x column. So y divided by x, that is 2, 6 divided by 3 is 2, 10 divided by 5 is 2, 14 divided by 7, that's 2, 18 divided by 9 is 2. So what's our k? Our k is 2, and this will be an example of direct variation. For indirect variation or inverse variation, we multiply y times x, or you can say x times y, and you'll get an answer, and it must be the same answer. All right, so here we have our x column and our y column. So we have values for x and we have values for y. So I'm just going to multiply the x values, -6, with the y value, which is -4, and you get an answer of 24. If you take 12 and 2, you get an answer of 24. If you take -8 and you multiply by -3, you get positive 24. If you take -1 and you multiply by -24, you get 24. So what's our constant of variation? That will be 24. And this will be an example of indirect. Right. So what if we have a table and we do not know which formula to use? All right. Well, then you have to do the division first and then the multiplication second. So what does direct variation tell us? Direct variation tell us take the y and divide it by the x. So let's do that. So we say 6 divided by 24. Well, that will just give us 1/6. So if I divide 7 by 49, I should also get 1/6, which is the if I don't get the same answer, then it's not direct. Then we move on to indirect. Okay, so let's check that. So if I say 7 divided by 49, well, that is 1/7. So can you see 1/6 and 1/7 are not the same? So it's not direct variation. So let's try indirect variation. So indirect variation tells us that if we multiply these two numbers, we should get the same answer. So if I multiply 24 by 6, we get 144. If I multiply 49 times 7, I get 343. So immediately you can see not the same numbers. So you just need to check two numbers for direct variation, two numbers for indirect variation, and if you don't get the same answer, it's neither. All right, so this k, there's no k, there's no constant of variation because the numbers change, and so this will be neither. So it's neither direct nor indirect. Okay, hope that makes sense. Right, and of course you can see I've basically done the same with the first table. So for indirect, for direct, y divided by x. So this is my y, this is my x. So y divided by x. Well, that doesn't really work. So we try multiplication. X times y, or y times x. So 2 times 36, that's 72. 9 times 8, 72. 3 times 4, 72. 6 times 12, that's 72. So my k is 72. So it's definitely this one. So then if we write it in the y is equal to, sorry, let me just write it here. So my formula is y is equal to k over x. So y equals to, what's my k? My k is 72 all over x. Right, great. So this will be an example of indirect. So we check, and you can see I basically divided the y with the x, and I got 49 over 7. Divide the y with the x, we get negative 91 over 13. So you can see we don't get the same number, right? So if I say 49, I divide it by 7, I get 7. If I say negative 91 and I multiply it by negative 13, sorry, negative 91 multiplied by negative 13, I also get a weird answer right there. Okay. So you can see clearly that this will be direct variation. So the answer will be 7. And you can check it out. 49 divided by 7, 7. Negative 91 divided by negative 13, 7. Negative 42 divided by 6, 7. 203 divided by 29, 7. So that will be direct variation because y divided by x. So this one will be, so our k here will be 7. We use the same formula, which is y equals to, no, but in this case now, sorry, we use y equals to kx. So then it's going to be y equals to, what's my k? 7x. And this is an example of direct. Variation. So let's look at this one. If we multiply, we get negative 9 multiplied by negative 4, we get 36. If you multiply negative 18 times 2, we get 36. Negative 6 times negative 6, 36. Negative 12, negative 3, 36. When we multiply, that will be an example of indirect or inverse variation. So the k there will be 36. And then how do we write it? We write it, so that will be indirect or inverse because we multiplied. And what's the formula for indirect? That is y equals to k over x. So what is our k now? Our k is 36 all over x, and this is an example of indirect. And that, my students, is how we do it.